Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to business mathematics and statistics. This is lecture number 18, chapter 4, time value of money. Today we will start with the topic effective rate of interest. Effective rate of interest. If interest is compounded more than once a year, the effective interest rate for a year exceeds the per annum interest rate. If interest is compounded more than once a year, the effective interest rate for a year exceeds the per annum interest rate. Let us understand with example. Suppose you invest rupees 10,000 for a year at the rate of 6%. 10,000 rupees principal amount at the rate of 6% per annum, compounded semi-annually. Effective interest rate for a year will be more than 6% per annum since interest is being compounded more than once in a year. For computing effective rate of interest, first we have to compute the interest. So let us compute the interest. Now interest for first 6 months. So principal is 10,000. Rate is 6%. So 6 by 100 multiply with 6 by 12. Here for a year at the rate of 6% per annum, compounded semi-annually. So 6 by 12. Here 2 zeros cancel. 6 2s are 12. 2 3s are. So 100 multiplied with 3 is equal to 300. So this is the interest for first 6 months. Now principal for calculation of interest for next 6 months. Then principal becomes new. So here principal amount is 10,000. So 10,000 and the interest for first 6 months is 300. So add 300. So new principal amount is 10,000 and 300. Then 10,000 and 300. Now find the interest for next 6 months. 10,300 multiply with 6%. So 6 by 100 multiply with 6 by 12. 6 2s are 12. 2 3s are 2.2. So 103 multiply with 3. 3 3s are 9. 3 0 0 and 3 1s are 3. So that is rupees 309. Now total interest earned during the current year for the first 6 months plus next 6 months or second 6 months. So 300 plus 309 is equal to 609. Interest of rupees 609 can also be computed directly from the formula of compound interest. We can compute effective rate of interest by following formula. Effective rate of interest formula. I is equal to PET. I is where I is amount of interest. Capital E is effective rate of interest in decimal. T is time period. P is principal amount. Now putting the values we have here, I is equal to PET. I is equal to PET. I is equal to interest 609. P is equal to 10,000. Capital E, what we have to find out, and T 1. So capital E is equal to 609 upon 10,000 into 1, 10,000, so 609 divided by 10,000. So it is 6.09%. In terms of percentage, it is 6.09%. Next. Thus, if we compound the interest more than once a year, effective interest rate for the year will be more than the actual interest rate per annum. But if interest is compounded annually, effective interest rate for the year will be equal to actual interest rate per annum. So, effective interest rate can be defined as the equivalent annual rate of interest compounded annually. If interest is compounded more than once a year, effective interest can be defined as equivalent annual rate of interest compounded annually. When interest is compounded more than once a year. So the effective interest rate can be computed directly by the following formula. Capital E is equal to 1 plus I raised to n minus 1. E is the effective interest rate, I actual interest rate in decimal, and n number of conversion period. N is equal to number of conversion period. Now, example, rupees 5,000 is invested in a term deposit scheme that fetches interest 6% per annum compounded quarterly. What will be the interest after 1 year? What is effective rate of interest? Here 5,000 is invested, so P is given. 5,000 is P. Scheme that fetches interest, so 6%. I is given. Per annum compounded quarterly. It means N is equal to 4. What will be the interest after 1 year? What is effective rate of interest? Effective rate of interest. So, I is equal to P in the bracket 1 plus I raised to n minus 1. We know that I is equal to P in the bracket 1 plus I raised to n minus 1. So put the value P is equal to 5,000, I is equal to 6%. So 6% by 6 by 100. 6 by 100. And per quarter, here per quarter, so 1 by 4. So 2 3s are 6, 2 2s are 4, 2 1.5. So it is 15 by 1000. So it becomes 0.015 per quarter. N is equal to 4. and I, capital I, is equal to amount of compound interest. Putting the value I is equal to 5000 in the bracket 1 plus 0.015 raised to 4 minus 1. 5000 into this bracket value we will find out using Kelsey. So 1.015 raised to 4 minus 1. This value is, or answer is 0.061366355. Multiply with 5000. So it becomes 306.82 rupees 306.82. For effective rate of interest using another formula, I is equal to PET. So 306.82 is equal to 5000 into E. T for 1 year, so 1. So E is equal to 306.82 divided by 5000. So the answer is 0.0613, or we can write as 613 by 4. So it is 6.13 upon 100. So it is 6.13%. Now, note, we may arrive at the same result by using capital E. Effective rate of interest is equal to 1 plus I raised to n minus 1. So 1 plus 0.015 by 4 minus 1. 1.0613 minus 1. It is 0.0613 or 6.13%. So instead of use this lengthy method, you can simply get the result by putting this equation E is equal to 1 plus I raised to n minus 1 and get the answer. Okay. Now, we may also note that effective rate of interest is not related to the amount of principal. We may also note that the effective rate of interest is not related to the amount of principal. It is related to the interest rate and frequency of compounding the interest. In this formula, E is equal to 1 plus I raised to n minus 1. Principal is missing. So, capital E, or effective rate of interest, is not related to the amount of principal. There is no relation between effective rate of interest and principal. There is a relation between capital E, means effective rate of interest, is related to interest rate I and the frequency of compounding the interest n. So E is related with I and n. So keep in mind that next example, Find the amount of compound interest and effective rate of interest if an amount of rupees 20,000 is deposited in a bank for 1 year at the rate of 8% per annum, compounded semi-annually. So here P is given 20,000 deposited. Find the amount of compound interest and effective rate of interest if an amount of rupees 20,000 is deposited in a bank for 1 year at the rate of 8%. So I is given per annum. I is given but per annum, annually. Compounded semi-annually, here compounded semi-annually. So 8% means 8 by 100. Semi-annually means 1 by 2. 2 fours are 8. So 0.04. I is equal to 0.04. So interest I is equal to, formula is P in the bracket 1 plus I raised to n minus 1. P is given 20,000, I is equal to 0.04, n is equal to 2. I is equal to 20,000, put the value in this formula. 1 plus 0.04, 2 raised to 2 minus 1. Using calc, you can solve this. And here we get 0.0816. So 20,000 multiply with 0.0816. So the answer is 1632. 1632. Now, effective rate of interest. There is a formula I is equal to capital P, capital E into T. Here we have to find out E, effective rate of interest. So, put the value. I is equal to 1632, P 20,000, T for 1 year. So, capital E is equal to 1632 divided by 20,000. So, we will get 0.0816. 0816 is equal to 816 by 10,000. So, 8.16 by 100. So, converted into percentage, 8.16 percentage. Effective rate of interest can also be computed by the following formula. There is an easy way. E is equal to 1 plus I raised to n minus 1. 1 plus 0.04 square minus raised to 2 or square minus 1. So, using calc, solve this and we will get the answer 0.0816. So, 8.16 percentage. Next example. Which is better investment, 3% per year compounded monthly or 3.2% per year simple interest, given that 1 plus 0.00225 raised to 12 is equal to 1.0304. Which is better investment, 3% per year compounded monthly or 3.2% per year simple interest. So, given that 1 plus 0.00225 raised to 12 is equal to 1.0304. Here I is equal to 3 by 12. I is equal to 3 by 12. Is equal to 0.25 or 3%, so 100. 0.25 by 100 is equal to 0.0025. There is a mistake. So 3 by 12 into 100, because 3 here 3%, n is equal to 12. Compounded monthly, so n is equal to 12. E is equal to 1 plus I raised to n minus 1. So 1 plus 0.0025 raised to 12 minus 1. 1.0304 is given. Minus 1 is equal to 0.0304. So 304, 10,000. So 3.04 by 100. In the terms of percentage, 3.04%. Effective rate of interest is being less than 3.2%. The simple interest 3.2% per year is the better investment. Effective rate of interest is being less than the 3.2% per year. The simple interest 3.2% per year is the better investment. Now, choose the most appropriate option A, B, C or D. Now, solve with if P is equal to rupees 1000, R is equal to 5% and N is equal to 4. Here given per annum. What is the amount and CI, compound interest, is? Now, tell me, which formula we have to use? Which formula? Think. So, now, see here, amount A is equal to P into 1 plus I raised to n. Interest rate, or here capital R, so 1 plus R raised to n. So, P is 1000 given, P is 1000 given, 1000, 1 plus rate 5%, so converted 5 by 100, n is equal to 4 is given, raised to 4. So 1000, 100 plus 5 upon 100 raised to 4 is equal to 1000, 105 by 100 raised to 4 is equal to 1000, 1.05 raised to 4. Now solve with calci. So the answer is 1215.50. So amount is 1215 rupees 1215.50. Now find out the compound interest. So compound interest formula is compound interest formula is, do you know na? A minus P. It is A minus P. So amount is 1215.50 minus P is given already, 1000 minus 1000. So answer is 215.50. compound interest is 215.50. So the answer is A, rupees, amount is 1215.50 and compound interest is rupees 215.50. Now next question. The difference between compound interest and simple interest on a certain sum of money invested for 3 years at 6% per annum is rupees 110.16. The principal is, here we have to find out the P. So the simple interest formula is, here rate is given, P interest, so PRT or PIT, PRT. So P is, here P is unknown, so we have to find out. R is 6%, so 6 by 100 into T is invested for 3 years, multiply with 3, is equal to 3 6 are 18. 18P by 100 is equal to 0.18P. Now find out the compound interest, is equal to A minus P. A is also P 1 plus I or 1 plus R raised to N minus P. Amount equation is P into 1 plus R raised to N, or amount equation is P 1 plus I raised to N. P is given or unknown. P is unknown, so take common P. So 1 plus R, rate is 6%, 6 by 100 raised to N means 3 years. So 3 minus 1. P, it is 100 plus 6, 106 by 100. So 1.06 cube minus 1 is equal to, solve by Kelsey, we will get 0.191 P. 0.191 P. Now here the difference between compound interest and simple interest is given, rupees 110.16. So compound interest, simple interest. Compound interest is 0.191 P. Simple interest is 0.18 P. So minus difference is given 110.16. 0.191 minus 0.18 is equal to 0.011 P. So P is equal to 110.16 by 0.011 is equal to 10,000. is equal to 10,000. So P is equal to 10,000. So answer is D. Answer is D. Now next question. The difference between the SI and CI on rupees 2,400 for 2 years at 5% per annum is, here what we have to find out? Simple interest and compound interest difference. So simple interest equation is PRT or PIT. PIT. P is given 2,400. I or interest rate R 5 by 100 for the 2 years. So multiply with 2. P is equal to 2,400. I is equal to 5 by 100 and T is equal to 2 years. So 0 0 cancel. 24 into 10 to 40. So simple interest is 240. Now compound interest is equal to A minus P. A is equal to, here, P 1 plus I raised to N. So put the value P 1 plus I raised to N minus P. P common, so it is 1 plus 5 by 100 is 0.05. 1 plus 0.05 raised to N for 2 years, 2 minus 1. So P, by solving calci, we will get the answer. Put the value of P here. Value of P is 2400 into 1.05 square minus 2400. So after solving this, 2646 minus 2400 is equal to 246. Now take the difference between compound interest and simple interest. Compound interest is 246. Compound interest is equal to 246 and simple interest is equal to 240. So compound interest minus simple interest is equal to 246 minus 240. So is equal to 6. Is equal to 6 rupees. So the answer is D, 6 rupees. Now move to the next question. The compound interest on rupees 4,000 for 6 months at 12% per annum payable quarterly is. So the compound interest on rupees 4,000. So P is equal to 4,000 is given for 6 months, 12%. So I is equal to 12% is equal to 12 by 100 per annum payable quarterly. Payable quarterly. So T is equal to here 6 months. So n is equal to 12 by 6. 6 2s are 12. So n is equal to 2. And here payable quarterly. So 12 by 100 multiply with 1 by 4. 4 3s are 12. 3 by 100 is equal to 0.03. So I is equal to 0.03. Now compound interest is equal to P in the bracket 1 plus I raised to n minus 1. Put the value P 4000. 1 plus I is equal to 0.03 raised to n is equal to 2 minus 1. So compound interest is equal to 4000 1.03 square minus 1 is equal to, after solving this, we will get the answer 243.6. So compound interest is rupees 243.6. So the answer is A. Answer is A, rupees 243.6. This lecture is over here. So bye bye. Take care.